In a previous lesson, we walked through the basic rules of alkane nomenclature, and you might have noticed that they're not actually that basic. And now we're going to add to those basic rules of alkane nomenclature to look at some more complicated examples. So I'm going to look at this compound first. We'll move that over to ChemDraw. But before we dig into this one, let's just kind of recap some of the basic ideas about alkane nomenclature. When you name an alkane, the first thing that you want to do is identify the longest continuous chunk of carbons. For this compound right here, there are 1, 2, 3, 4 carbons. So this is some type of butane. And then once you've determined the longest continuous chunk of carbons, you have to figure out which position to call the number one position. It's either going to be this position here or this one right here. And if we call this the number one position, then my first substituent would be at the 2 position. If I call this the number one position, then my first substituent would be at the 3 position. You choose the numbering of your parent chain so that you encounter the first substituent at the lowest number possible. And so this is the number 1 position, that's the 2 position, and at the 2 position I have a methyl group. So the name of this compound right here would be 2-methyl butane. Numbers are separated from letters by dashes, and then we just run the substituent name directly into the parent chain name. For this compound up here, we have to do the same thing. We look for the longest continuous chunk of carbons, and it's probably this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. But we also have to explore some other options. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So this looks to be the longest continuous chunk of carbons right here. So I'm just going to kind of indicate this as my parent chain. I have to decide which of the 2 ends I'm going to call the number 1 position. If I start from this end, then my substituents are coming off of the 1, 2, 3, 4 position, and then the 5 position. So we write that down as a numerical pattern. So things are coming off of 4 and 5 if I start on the right side. And if we start on the left side, it's 1, 2, 3, 4, 5. Then things are coming off of the 5 and the 6 positions. You compare these 2 strands of numbers, starting with the first point of difference. And a 4 is lower than a 5. So that's going to be the way that we're going to name this thing. So this right here is going to be carbon number 4. And then we're going to have carbon number 5 at this position right here. Now you might already notice something that is different from previous examples, and that is that my substituents also have branches. In the past, I avoided giving you anything that was that complicated. This would be more similar to the example that I gave you before. And the name of this compound right here would be at the 4 position we would have an ethyl group, and at the 5 position we'd have this propyl group. And our parent chain would be a nonane because there are 9 total carbons. And so now we just kind of put all those pieces together. This is an ethyl group coming off of the 4 position. Our propyl group is coming off of the 5 position. And we can just kind of stitch these together alphabetically. So ethyl comes before propyl, comes before nonane, and then we just tack these together here with a hyphen. And kind of make these pieces fit. So this is how we would name the compound that is not the one that I gave you, but this compound that I've edited. So now let's go ahead and add back in some of that complexity. So we're going to put this methyl group right back here. And what that does is it generates kind of a 3-generational problem. So we still have the same parent chain. This is a nonane, so I'm going to go ahead and write that down. But coming off of the nonane is a 3-carbon chunk. So coming off the nonane, now this carbon is part of the parent chain. So I'm going to count coming off of the nonane where this is the number 1 carbon, this is the number 2 carbon, and this is the number 3 carbon. So there's a propyl group coming off of this nonane. And the propyl group is coming off of the 5 position, but we'll deal with that later. Coming off of the propyl group is this methyl group. So notice how the methyl group is not connected to the parent chain, but instead is connected to the substituent. And the way we discuss this, the way we describe it, is that this is the parent chain, and this is a parent substituent. And this is a substituent now. You can think about this as the grandparent and the parent and the grandchild. And so we have 3 generations now. You could imagine a system that would be more complex with a branch coming off of the branch coming off of the branch. That 4-generational type problem is not one that I'm going to show you in this course. So 3 generations, or a parent chain, and then a parent substituent, and then a substituent coming off of the parent substituent, is as complicated as we'll get. So now we have a methyl group, and the methyl group is coming off of the propyl group. It's not coming off of the nonane. Okay? So we have a methyl coming off of a propyl, and then the methyl propyl group is coming off of the nonane. And the way that we show this is with parentheses. So I'll stop being so cute with the stitching. This is a methyl propyl group, and what we do is we put all of this in parentheses. And these parentheses are important. What they do is they communicate that I have something coming off of the nonane, and that something is a propyl group. And then there is also something coming off of that propyl group. The parentheses tell me that the methyl group is not connected to the parent chain, but instead is connected to the other thing inside of the parentheses. The numbering of the parent substituent starts here. This is the number 1 position. So we have kind of this secondary numbering system. And so this is the number 1 position of the propyl group. So we can say that the methyl group is actually coming off of the number 1 position of the propyl group, and that goes inside the parentheses as well. And this now methyl propyl group that's coming off of the parent chain is coming off of the 5 position. So this whole thing right here is now a 1-methyl propyl, and it's coming off of the 5 position of the nonane. So let's go ahead and write nonane on here. Then I can stop floating that word around. Now, I'm not done yet because I haven't dealt with what's going on at the 4 position, but what I've shown you is the basics of how you would... So let's just cut this 4 position off right here. And now this is the correct name for this compound right here. At the 5 position, the parentheses tell me that I have something, and that something is complicated. It's called a branched substituent. So at the 5 position of my parent chain, I have a branched substituent. Digging into that branched substituent, there is a propyl group that is extending directly out from my parent chain, and then coming off of the propyl group at the 1 position of the propyl group is a methyl group. 1s are entirely optional, and so if you leave a 1 off, then we just assume that you meant it. So this would also be a correct name for this compound, an equally correct name. So let's go ahead and start growing out this second substituent. And so right now, at the 4 position, I have a methyl group. And we can name this compound right here. At the 4 position, I have a methyl group. And at the 5 position, I have a methyl propyl group. The numbering is still based on the fact that if I number it from this end over here, I encounter this substituent as quickly as possible. But now when I try to put these 2 in order, I have a 4-methyl group and I have a 5-methyl propyl group, we alphabetize them. Methyl comes alphabetically before methyl propyl because it ends first. A shorter word is given alphabetic priority, as you learned forever ago. So if your job was to write phone books, then you would need to know that the word that ends first comes alphabetically first. John comes before Johnson. And so methyl comes before methyl propyl right here. And so this would be a correct name for this compound right here. If we continue to grow this, so now I'm going to add another methyl group to this. So now it's an ethyl group. It's still coming off of the 4 position, and alphabetically, E comes before M, so this stays the same. Now, if we add another methyl group right there, this is another one of these messes. So at the 4 position, I have a substituent with a branch coming off of it, and at the 5 position, I have a substituent with a branch coming off of it. These branched substituents get parentheses. So now instead of being a 4-ethyl group, I'm going to rewrite this. This is now coming off of the 4 position. I have a branched substituent. Branched substituents always get parentheses. The longest continuous chunk of carbons, not counting the carbon that's part of the parent chain, but moving one over so that this becomes the number 1 position, is a 1 and then 2. You can go 1, 2, either direction. Either way, this is an ethyl group that's coming directly off my parent chain. And then coming off of the ethyl group is a methyl group. So this is called a methyl-ethyl. And it's coming off of the 1 position of the ethyl group, but 1s are always optional. So if you just leave that 1 out, then it communicates exactly the same thing to your audience. So again, the way to think about this is at the 4 position, I have a branched substituent. That's where the parentheses are there. When I unpackage that branched substituent, the longest continuous chunk of carbons, there's 2 of them. So this is an ethyl group. And then breaking off of that ethyl group at the 1st position is a methyl group. But what if we broke it off of the 2nd position and put that methyl group over here off of the 2nd position? Well, now it's no longer a methyl-ethyl group. This is just a propyl group. It's not a branched substituent. So if this were the substituent, it would just be a 4-propyl. Okay. But it's not. The methyl group, I want the methyl group to be over here on this position, and so the correct name for this substituent is methyl-ethyl. Now if I try to write out the full name of the compound, I am alphabetizing a methyl-ethyl versus a methyl-propyl. Alphabetically, methyl followed by the letter E comes before methyl followed by the letter P. So this would be the correct name of the compound as it currently stands. Propylnonane. Let's, all right. But we still haven't even gotten to the practice question I wanted you guys to look at. Notice that in the practice question, there's another methyl group right there. And you'll notice that that methyl group is not connected to the parent chain. It comes off of the 1st carbon of this branched substituent. And so let me draw that in. So if you look at the 4th carbon right here of the parent chain, and then count directly out from that 4th carbon, you have the 1st carbon is here. The 1st carbon is always the carbon that is directly connected to the parent chain. And then the 2nd carbon is moving out from that 1st carbon. So this is the 1st carbon right here, and this is the 2nd carbon right there. And now I've accounted for the longest continuous chunk of carbons that extend directly out from the parent chain, and it's still an ethyl group. So I have an ethyl group at the 4 position, and I have this methyl-propyl group still at the 5 position. Coming off of this ethyl group at the 1 position is a methyl and then another methyl. So if you remember when we had multiple substituents of the same flavor, this is now a dimethyl. We should call this a 1,1 dimethyl. And so this is now kind of the most tedious correct name for this compound right here. Because, oh wait, now we put another 1 in here. Now it's the most tedious correct name for this compound. We've identified the 2 locants, the number 4 and the number 5, are where things are branching off of the parent chain. In parentheses, I put those branches in parentheses because they're branched substituents themselves. So there's something coming off of the thing coming off of the parent chain. And then coming off of the ethyl group, I have 2 methyl groups. So that's a dimethyl. And coming off of the propyl group, I have another methyl group here. Notice how the 3 methyl groups are not lumped together and there's no trimethyl anywhere. Once you introduce the concept of parentheses, then you need to keep everything inside the parentheses that is coming off of that numbered position of the parent chain. This is a correct name for this compound. It's not the only correct name for this compound. And in order to understand what the second correct name for this compound is, we need to first think about the concept of primary, secondary, tertiary, and quaternary carbons. You can think about the airy is kind of the superscript O right here. This is the common abbreviation. So when we talk about primary, secondary, and quaternary carbons, we often just use these numbers with that superscript O as an indication of primary, secondary, tertiary, and quaternary. Let me spell this out for you. Primary is often written just as one naught. This is secondary. This is tertiary. And this is quaternary. All right, we can go ahead and label each of the carbons in this structure as primary, secondary, tertiary, and quaternary. So let me get rid of all the other marks all over this thing. And what I'm going to do is anything that is primary, I'm not going to bother labeling. I'm just going to leave it unlabeled. So we'll start with the secondary. What secondary refers to are carbons in an alkane that are connected to exactly two other carbons. So this right here is an example of a secondary carbon. It is connected to a carbon over here and a carbon over here. So what I'm going to do is put just this little box. So here's my key. Secondary are shown with that dashed line box. Here's a secondary carbon that's connected to two other carbons. There's a carbon connected to two other carbons, two, two. All right, I've identified all of the secondary carbons right here. Tertiary carbons, we'll go ahead and put this oval around any of the tertiary carbons. And a tertiary carbon is a carbon that's connected to three other carbons. Well, this carbon is connected to one other carbon, so no. This carbon connected to one other carbon. So this carbon is not tertiary, but this carbon is. Notice how it's connected to 1, 2, 3 other carbons. So this is a tertiary carbon. Let's see, I've got one more tertiary carbon right there and another tertiary carbon right here. And so those are my 3 tertiary carbons. They are carbons that are connected to 3 other carbons. Finally, we're going to do the quaternary carbons, and I will do those with a solid box. Quaternary carbons are carbons that are connected to 4 other carbons, and there's just one of those right there. I guess for the sake of completion, we should go ahead and put the primary carbons in a circle. And the primary carbons, if you haven't guessed it, are the carbons that are connected to just one other carbon. So this is a primary carbon. This is a primary carbon. Primary. And this has quite a bit of overlap with the earlier idea of methyl, methylene, and methine carbons. So a primary carbon will also be a methyl group. A secondary carbon will generally be, and generally because there are some exceptions, but a secondary carbon will generally be a methylene carbon, and a tertiary carbon will be a methine. So methyl, methylene, and methine. Quaternary carbons don't get this additional name. So all the circles now contain primary carbons, or in other words, all the circles contain methyl groups. All of the dashed boxes contain methylene carbons or secondary carbons. All of the ovals contain tertiary carbons or methine carbons. So those terms, when we're dealing with alkanes, are redundant. But we like redundancy, so we use them all the time anyway. All right, that's a long introduction to get you to the next concept, and that's this idea of common names. So the rules of nomenclature were invented long after chemists were already working with compounds. So they didn't really come up with rules. They just kind of had common names that they would give them as kind of a shorthand way of describing something. And the common name focuses on these substituents and just kind of focuses on how many total carbons does the substituent have. And that's the origin of the common name. So instead of thinking of this as an ethyl group with 2 methyl groups coming off of it, the common name just identifies, well, how many total carbons are there? And there are, if we count, inside of this brackets right here, there are 1, 2, 3, 4 total carbons. So instead of calling it dimethyl ethyl, they decided they're going to call this some type of butyl group. And now it's got a YL ending because it's not a parent chain, it's substituent. It's a substituent. But this substituent here also has 4 carbons. So this is a type of butyl group as well. And we need to come up with some difference between these two butyl groups that allows us to name them. And what they decided to do was name it based on the type of substituent that it is. And what they did is they said, well, if you cut that substituent off, right, and just disconnect it from the parent chain, then what kind of carbon is it right here? What type of carbon is this? And then what type of carbon is this? What does the carbon look like that is directly connected to the parent chain before it was ever connected to the parent chain? And the answer is, well, this used to be a tertiary carbon on top, and the carbon on bottom used to be secondary. And so we're going to refer to this substituent right here as a tertiary butyl group. And we're going to refer to this substituent down here as a secondary butyl group. And this is really quite confusing because when we name them as butyl groups, they're still connected to the parent chain. Okay? And we just identified that the carbon that connects directly to the parent chain in a tertiary butyl group is actually a quaternary carbon. And the carbon connected to the parent chain in a secondary butyl group is actually a tertiary carbon. So they didn't make this easy for you unless you kind of think about, well, what was it before we connected it? So, well, this used to be a tertiary carbon, and this used to be a secondary carbon. So we're going to call this a tertiary butyl group, and this is a secondary butyl group. And then even worse, they realized, well, tertiary is a lot to say, so we're going to refer to this as a tert butyl group. And then a handful of people got even lazier, and they started calling it a T-butyl group. So you'll see both of these as common ways of naming this chicken foot thing right here. It's either a tert butyl group or a T-butyl group. And the same goes down here. This is called a sec-butyl group, and then sometimes it's just called S-butyl. And so what this does is it gives us a different way of naming this compound. So I said that this name right here is one correct name for this compound. But if we use these common names, then there is an additional correct way of naming this one. So if we put all those pieces together now, we're going to show you what the second name looks like. Let me just kind of clean this up a bit. So it's still a nonane. And coming off of the nonane at the 4 position, I have a tert butyl group. So coming off of the nonane at the 4 position, I have a T-butyl group. And then coming off of the nonane at the 5 position, I have a sec or S-butyl group. And this is almost a correct name for this one. Again, it would be equally correct for us to go ahead and call this tert and to call this sec. And so let me edit those down. So these are two nearly correct names for this. The one thing that's missing is this T gets italicized. And you don't have to write it italicized because that's not a skill set that you need for this. It's like calligraphy is not a prereq for this course. But when you see it printed, they always italicize that. And the I don't know how to say that, italicization, the fact that you italicized it, is due to the problem with the way that we have punctuation here. In the past, I've said that numbers are separated from letters by hyphens, and letters are not separated from letters at all. But yet we have a number that's separated from a letter by a hyphen, which is what you'd expect, and then this letter is separated from another letter by a hyphen as well. So the italicization, I'm going to go with that, means that this is a letter, but it's also kind of a number. And so so it kind of gets treated as both, and the punctuation is a little goofy. That's why when they came up with this, they decided, it's weird to have all these different systems of nomenclature. Let's just come up with a standard system, and so they started using these parentheses. The nice part about common names is now you don't have to worry about the parentheses anymore. You just say, at the 4 position, I have this thing coming off. This thing happens to be a tert butyl group. And at the 5 position, I have this thing, and this thing happens to be a sec butyl. Now the question is, how did I decide which of those two to put first? And the short answer is, well, they both start with the letter B. So when you're alphabetizing your substituents, the sec and the tert are not used when we go ahead and alphabetize these. And that's because they're supposed to be numbers, and you don't alphabetize with numbers. The only time that you ever alphabetize sec and tert is when both of them happen to be on the same compound. So it's kind of a tiebreaker. So this right here is the name of this compound if we're using common names, and this is the name of the compound if we're using systematic names. Both names are correct. The one thing you can't do is mix and match. So you can't call you couldn't call this a sec-butyl and then in the same name switch from common names back to systematic names. So you can't like mix and match. So if you're going to call this one a sec-butyl, then you've got to call the other one a tert-butyl. If you're going to use the systematic name and call it a dimethylethyl, call your tert-butyl a dimethylethyl, then you have to call your sec-butyl a 1-methylpropyl. All right, if we go back to the original worksheet of what it is we're supposed to be doing, so for each of these compounds, we named the compound, and then we're going to rename the compound using common names. So for this compound right here, we've actually already done number 1A and number 2. Then we identified the carbons, that should be plural, carbons as primary, secondary, tertiary, or quaternary, and that was the whole purpose of my Lucky Charms. I got a circle and then a rectangle and then an oval and a solid square rectangle, whatever. This is my labeling of the carbons. And then the last thing I need to do is identify the substituents as primary, secondary, or tertiary. Now you'll notice that substituents are never quaternary. And this has to do with that idea of disconnecting them and then asking what the carbon is. So when you have a substituent, the substituent is primary, secondary, or tertiary based on the carbon that is directly connected to the parent chain. So whenever I see a substituent, if somebody asks me, is that substituent primary, secondary, or tertiary, then you just look at the carbon that is directly connected to the parent chain and you kind of subtract 1. So if the carbon is quaternary, which is what my solid rectangle is supposed to represent, then that means that my substituent is a tertiary substituent. So this is a tertiary substituent because the carbon directly connected to the parent chain is quaternary. So you just kind of subtract 1 from whatever the carbon is. This substituent is tertiary. This substituent down here on the bottom, you should remember, is a secondary substituent because that's where the common name comes from. But what we're really doing is we're looking at the carbon that is directly connected to the parent chain. We determine that the carbon itself is tertiary. That's what the oval means. And therefore the substituent is just 1 less than whatever that carbon is. And you have to pick the carbon that's connected to the parent chain. So if the carbon is tertiary that's connected to the parent chain, then the substituent itself is secondary. And now we can take this as kind of our complete answer. We've done all of the things the question asks me to do, and I'm going to draw that in right there. Whoa, that got big. This is going to be a mess by the time I'm done. Hopefully on your papers you can write this in a little bit more efficiently than I'm doing it. So this is a full set of answers for the first part of the first question. And I'm going to go ahead and drop in this common name before I forget of that compound as well. So we'll go ahead and rename the previous examples using common names. And so this is the first one. The first one was 5-sec-butyl or S-butyl, whichever you want to call it. And if you're writing it, you don't have to italicize it. But since I'm typing it, and it'll bug me if I don't, I'm going to go ahead and italicize that. Okay, now let's move on to, let's do the third compound. It illustrates a new concept, but it is quite a bit easier. So I'll go ahead and open up ChemDraw. Let's see, I'm going to go ahead and keep my legend so that I have all the same stuff. I don't need this anymore. Or that, or that. there's a lot of stuff I don't need. Let me just move this down here and then clean all this up. Okay, and then we're going to drop this compound in. Okay, so this is the next compound that we want to look at. And let's go ahead and assign the carbons and the substituent. A primary carbon is one that is connected to one other carbon. So it's also a methyl group. Remember that primary carbons and methyl groups are the same thing. The secondary carbons, we want to use the rectangle, are the ones that are connected to two other carbons. So this is a secondary carbon. That's secondary, 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 secondary. And the last two I have are tertiary carbons, and there's only two other carbons remaining, and both of them happen to be tertiary. Notice how there's no quaternary carbons in this compound, and that's certainly allowed. It's not like there's a rule that you have to have one of each type. So this is me labeling what all the carbons are. And then I'm going to go ahead and there's one substituent coming off of this. We determine what the substituent is by looking at the carbon that's directly connected to the parent chain. And this carbon right here is tertiary. The substituent is always one less than that. So this is a secondary substituent. And since I've already identified that key on the previous question, I'm just going to drag and drop this over. And the last thing we'll have to do, let's come up with a name first. So going back. All right, for nomenclature of this compound right here. Clean this up a little bit, just drag it down here so that we don't have to look at everything. For the nomenclature of this one, we now have for the first time a cyclic system. So a cycloalkane is one that makes a ring, and the ring itself does not inherently have any greater priority. And what I mean by that is when I'm looking for the parent chain, I'm still looking for the longest continuous chunk of carbons. And so this right here is a 4-carbon group. So I can call this carbon number 1, carbon 2, carbon 3, carbon 4. And then this one down here has 5 carbons inside the ring. 1, 2, 3, 4, 5. Now, one of the things that you can't do, and sometimes students make this mistake, is you cannot count a parent chain into a ring system. So in other words, you can't think to yourself, well, this right here, my longest chunk of carbons, would actually be 1, 2, 3, 4, and then you just keep going in the ring system, 5, 6, 7, 8. So this is invalid. A ring system is self-contained, and so you have to count the ring system by itself. So what I'm doing here is I'm comparing a 4-carbon group with a 5-carbon group. 5 carbons is a greater number. So this is some type of pentane, and it's a cyclopentane. Coming off of the cyclopentane at the numbering system now I have to fix. So these numbers I was using was just to keep track of the number of carbons, but now we have to number them. And what's different about cyclic ring systems is the number 1 carbon can be any one of the carbons in the ring. So any one of these carbons could be the number 1 carbon. I want to choose the numbering pattern that allows me to have a substituent coming off as quickly as possible. So in a case where there's just one substituent, that's definitely going to be your number 1 carbon. So coming off the cyclopentane at the number 1 position is a branched substituent. And so when you have branched substituents, that means at the number 1 position I have something interesting, and then I have a cyclopentane. That something interesting is a branched substituent, so I need to count the number of carbons directly extending out from my parent chain. 1, 2, 3. So this is a propyl group. And then coming off of the propyl group, I have a methyl group. So the correct name for this compound, the most tedious possible correct name, would be 1-1-methylpropylcyclopentane. Where this first one right here, out on the end, is telling me that off of the 1 position of the cyclopentane, I have something, and that something is in parentheses, and then the second one is telling me that off of a propyl group at the 1 position, I have a methyl group. Because ones are redundant, that means that it is equally correct. and perhaps a bit more common to just refer to this as a methylpropylcyclopentane. What happens if we get rid of the parentheses entirely? Right? What is the difference between methylpropylcyclopentane with parentheses and methylpropylcyclopentane without parentheses? And the answer is, well, we can actually do, this is what ChemDraw, this name appears to be ambiguous. The methylpropylcyclopentane without parentheses forces you to assume that everything is coming off of the parent chain. So the parentheses tell me that that methyl group is not coming off the parent chain, but instead it's coming off of the propyl group. If I drop the parentheses, then I'm left to assume that both the methyl and the propyl are coming off of the parent chain. So these two compounds are not the same. That's why the parentheses are a big deal. Okay. So we've now named the compound, we have identified all the carbons as primary, secondary, tertiary, and quaternary, and we have identified the substituents as primary, secondary, and tertiary. So let's go ahead and drop that compound in, and now we have this last one. And I saved it to the end because it's kind of a nasty beast. I really should go back and edit out nasty beast because a grown man doesn't say that about a chemical. Oh well. All right, let's go ahead and do this next one. This is the chemical right here, and we want to come up with a name for this one. And we'll do that, and then we'll go ahead and assign all the carbons and everything else on it. So looking for the longest continuous chunk of carbons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. I think that's it. So it's a little hard to see this one, so I'm going to go ahead and color this one in so you can kind of tell what the parent chain is. So this is part of my parent chain. And then I've got, these carbons are part of my parent chain. And then this is part of, so the parent chain now is shown in blue. And I have to decide whether to call this the number 1 position, and that gives me my first substituent at the number 3 position, or I have to call this the number 1 position, which puts my first substituent at the number 4 position. So this is going to be my number 1 position. I need this 3 right here. So that's a 3, and then a 4, and then I have 2 5s. And notice that if you number it the other way, it goes 4, 4, 5, 6. So the locant pattern is 3, 4, 5, 5 in the way that I've chosen. If I would have numbered it from the other position, it's 4, 4, 5, 6. And you might ask, well, wouldn't it be better to have 2, 4? No, you just look at the first point of difference. I'm comparing this 3 versus this 4. The 3 wins, and so I don't have to look at anything else. All right, coming off of the 3 position and the 5 position. So I have a 3, 3, 5 trimethyl. And then at the 4 and the 5 position, I have a similar but a branched substituent. And then my final compound is going to be some type of 1, 2, 3, 4, 5, 6, 7, 8 octane. So those are the pieces of the name. It's going to be a 3,3,5 trimethyl, a 4,5 something else, and then an octane. Okay, now let's dig into the parentheses here and figure out what this thing is called. So at the 4 and the 5 position, I have, if we extend directly out from the parent chain, but not counting this carbon twice. So I've already counted this carbon as part of my parent chain. So I don't start counting my substituent until I step a carbon out. So this is the number 1 position of my substituent, and this is the number 2 position of my substituent. So this is some type of ethyl group. And then coming off of the ethyl is a methyl. So this compound is a methyl ethyl. Notice how these are not in alphabetic order, and that's because the ethyl is the one that is connected directly to the parent chain, so that always gets written last, and the methyl is coming off the ethyl. And so you want to put the thing that's connected to the parent chain last, and then alphabetize anything else that's connected to that ethyl group. And there just happens to be that one methyl group. This is coming off of the one position of the methyl group, and we have two of them. Now, if chemists were at all friendly to students, they would call this a di. And based on my tone and the way I said that, you can already tell it's not going to be a di. When you have multiple things in parentheses, instead of using di, tri, tetra, penta, etc., the things we use everywhere else, they decided to come up with a completely different system. And I believe it's based on Greek, and it's bis, tris, and tetrakis. So it would be bis, tris, tetrakis. I don't know what 5 is. We'll go pentakis, but I definitely won't show you examples of that, mostly because at that point the word just sounds ridiculous. So these are, right here, the 3 common prefixes that you have to know when you're trying to identify something that is in parentheses. And the punctuation here, it is what it is. The bis feeds right into parentheses. Because the bis designates a number, we don't use it to alphabetize. Because the tri designates a number, we also don't use that to alphabetize. So when I go to put these in order and to make my parent chain, I am comparing a methyl with a methyl ethyl. So let's kind of move some of these pieces out of the way. So the methyl alphabetically comes before a methyl ethyl. That feeds directly into your octane, and we need to put a dash right here. So this right here would be, oops, I wasn't supposed to show you that yet. This right here represents the name of this compound, and that's using systematic names and not common names. Now we just need to identify what the carbons are. And so we have primary carbons are shown in circles. So let's start dragging and dropping some of the circles right here. There's one of the primary carbons. And remember, primary carbons are just methyl groups and alkanes. So we can just kind of drop this on all of our methyl groups. All right. Got a few too many of these. Okay, and then the secondary carbons are the dashed boxes. That's a secondary carbon right there. We have tertiary. There's a secondary carbon. And there's a secondary carbon. My tertiary carbons are the ones that are connected to 3 other carbons. So that's tertiary. And that's going to be tertiary. And this one right here will be tertiary. And then the quaternary are the solid boxes. And so we have a quaternary right here and a quaternary right here. Okay, so now we've identified all of the types of carbons. I hope that's right. And now what we need to do is come up with the substituents. So these up here, this carbon currently is a primary carbon. And we identify substituents as being primary, secondary, or tertiary. And so a primary carbon would become something like, so if you subtract 1, that means that if the carbon is primary, then the substituent is going to be 1 less than that. So a zeroary, I guess. And they don't even bother to say that because primary substituents are just methyl groups. And so we don't bother to care about those. So I don't have to worry about calling this any type of substituents. It's just a methyl group. So instead, I'm just going to focus on those that aren't methyl groups. So this right here is a substituent that I need to come up with, and this right here is a substituent that I need to come up with. Both of those substituents are attached via a carbon that is currently tertiary, which means it used to be secondary before it was added into the system. So these are secondary substituents. And then I already have a secondary substituent label. I'll just drag that and drop that over here. So now what I've got is, I've got the name of this thing, I've got the systematic name, and I've got everything labeled on it. All the carbons are labeled. I think we're ready to move on to common names for this thing. All right, There we go. All right, so now let's rename all of these compounds using common names. And this gets pretty easy, actually. You'll find that common names are much more user-friendly when you have complicated compounds than the systematic names are. So for this one right here, I'll go ahead and grab this compound and then drop it down here so I can clean everything up. The common name doesn't change the parent chain. And so this is still going to be an octane. And the methyl groups don't have common names, so they're still going to be a 3,3,5 trimethyl octane. But now we have to deal with the common name for this substituent right here. Remember that the common name is based on the total number of carbons in the substituent. And this carbon, in this substituent, there are 1, 2, 3 total carbons. So this is a propane. The propane is a secondary propane, and so if we were at all consistent, we would call this sec propane, and we did not. For no good reason that is helpful, we just call this an isopropane. And because it's a substituent, we can't use the ane ending. This is an isopropyl substituent. And the isopropyl substituents are coming off of the 4 and the 5 position. And because there are no parentheses, we don't have to use the bis and the tris and the tetrachus. We can just call this a diisopropyl. So again, another reason why people use common names is so they can avoid the parentheses, but also so you don't have to use that odd Greek system of nomenclature, bis, tris, tetrachus. Once you use the common names, then you just call them di, tri, tetra, etc. Alphabetically, the tri refers to a number, so we don't use that to alphabetize. Instead, we use the M. This is M for methyl. And this one, the di, refers to a number. The iso doesn't tell us anything about numbers. It just is the name they gave it. So we use that to alphabetize. So this I comes before this M. So the full name of this compound then would be, let me give myself plenty of room to type. It would be a 4,5 diisopropyl -3,3,5 tetramethyl octane. And again, this kind of illustrates why we use common names. They're a lot easier to use if you know the common names. So our second compound is 4,5 diisopropyl 3,3,5 trimethyl octane. Now we want to come up with a common name for this compound. Let's get this thing all by itself. I thought one of the easier parts about remote learning would be not having to erase the chalkboard, but I have to erase ChemDraw all the time. Okay, so this is a cyclopentane. That is the longest continuous chunk of carbons. And then coming off of the cyclopentane is, if you remember this common name from before, but if you don't, then we'll go ahead and kind of show you how we build this name. There are 4 total carbons coming off of the parent chain on this substituent. And the substituent itself is secondary. The carbon that is connected directly to the parent chain is tertiary. The substituents are always kind of downgraded one level. So this is S-butyl. Sorry, when it's a substituent, it's a YL ending. So this compound would be called S-butyl cyclopentane, or also correctly called sec-butyl cyclopentane. So either one of those names is correct. Okay, so our third compound is done, sec-butyl cyclopentane. Let's take a minute and back up a second to look at the key concepts and provide some descriptive explanations. So branched substituents are substituents off the parent chain that have their own branches. And that's kind of what we've been looking at, the nomenclature for these ones today. Primary, secondary, tertiary, and quaternary carbons are bound to 1 carbon, 2 carbons, 3 carbons or 4 carbons respectively. And then primary, secondary, and tertiary alkyl groups are based on the carbon directly connected to the parent chain. And you subtract 1 from the carbon designation. That's probably the worst possible way of saying that, but good enough. What I'm trying to communicate with this is the idea that if your substituent is branched off the parent chain and the carbon of the substituent that is directly connected to the parent chain is secondary, then your substituent is called a primary substituent. Let's show that in the context of a couple of examples. So here is one of those. This compound right here is, well, its systematic name would be 2-methylpropane. But it does have a common name, one that we've actually seen this compound before. The common name for this compound is isobutane. And this carbon right here is part of the parent chain. We'll say that this is 1, 2, 3. There's the propane. And coming off of that is a methyl group. That's a primary carbon. So as a substituent right here, this would not be considered anything. But if we branch this off of something larger, for example, this compound, then this becomes my parent chain. This is a cyclohexane. And coming off of the cyclohexane is an isopropyl group. This carbon is a tertiary carbon, and so the substituent will always be 1 less than that. So this is a secondary substituent coming off of my parent chain. Common names is the next thing we want to look at right here, and I went ahead and made a list of some of the ones that you guys have already seen. Isobutane, neopentane, isopropyl, sec-butyl, and tert-butyl. So the isobutane I showed you just a second ago. Let me strip that back down again to isobutane. This is a common chain name for just a parent chain. Neopentane is this compound right here. It's 5 carbons where the center carbon is quaternary. If you branch the neopentane directly off of a parent chain like this, well, I didn't branch it off of a parent chain. So, sorry, the neopentane was a common name that you guys need to be familiar with. And now we're going to, so these are parent chain common names. Isobutane and neopentane. And then substituent common names are isopropyl, sec-butyl, and tert-butyl. So let's go ahead and build a compound that has those. So this cyclohexane is the parent chain. Coming off of it is a tert-butyl group. We could also build a sec-butyl group coming off of this. So here are 2 of the parent chains that you need to, 2 of the common substituent names that you need to know. And notice how they are alphabetized. So sec-butyl comes alphabetically before tert-butyl. We can also throw an isopropyl group in there. And the isopropyl group is alphabetized according to the letter I. Sec-butyl and tert-butyl are alphabetized according to the letter B. The only time we use sec and tert, which represent numbers, so we're not supposed to use those to alphabetize things, are when those are the only 2 things you have left to compare. So here is a compound that has 3 of the substituent common names that you need to know. There is another one that you guys need to know. So this is another butyl group, but it's an isobutyl group. So it's kind of like isopropyl in that it has this Y on it, but it's called isobutyl group. It's a 4-carbon Y that kind of sits one off. So here's another common name. The isobutyl group, this one right here, 1, 2, 3, 4 total carbons with that Y here on the end, that's isobutyl, is alphabetized according to the letter I. Isopropyl group is also alphabetized according to the letter I, but it comes before, isobutyl comes before isopropyl because iso-B comes before iso-P. Neopentyl is another common name that you need to know, and it's just a neopentane that's branched off the parent chain. So go ahead and draw that in there. And at this point, we're building a compound that I doubt has ever existed. This is now a neopentyl group, and it's alphabetized according to the letter N, because neo doesn't refer to any type of numeric designation. So let's just add in the rest of those common names. You should recognize an isobutyl group when you see one, and you should recognize a neopentyl group when you see one. Cycloalkanes are alkanes that make a ring, if you didn't already know what cyclo meant. Okay, so now let's name this monstrosity right here. And this particular problem, it takes a while to get through. And what it does is it contains all of the common names that you guys need to recognize. So first of all, hopefully let me just kind of highlight these common names, and I'll see if you can identify them. That's hard to identify simply because of where it's at. So I'll put that one here and that one here. And then you should recognize this one, and then also this one right here. So those are all compounds that have common names. And so take a minute, pause the video, and see if you know the names of all of these substituents right here. Okay, let's see how you did. So this right here is an isopropyl group. This is a sec-butyl group. Go ahead and make these words a little bigger. We have another isopropyl group right here, isopropyl. This is the isobutyl group. And this is my neopentyl group. And this right here is my tert-butyl group. These are supposed to be italicized. Now, one of these, just because all of them have common names that here, does not mean that everything in the structure can have a common name. So this right here doesn't have a common name. The longest continuous chunk of carbons that are directly connected to the parent chain is a cyclohexyl group. So the parent chain is a cyclohexane, and coming off of the parent chain is a cyclohexyl group. Both this cyclohexyl group and the parent chain cyclohexane have 6 carbons. The reason that I chose this to be my parent chain is because it has 6 carbons and it has the most substituents coming off of it. If I were to call this my parent chain, then it would only have 2 things coming off of it. Remember, when you have parent chains of equal length, then you choose the parent chain that has the most number of branches coming off of it. So this cyclohexyl group right here has a methyl group coming off of it. And because then it's a branched substituent, it's a substituent with stuff coming off of it, that needs to go in parentheses. And the methyl group is not coming off of the number 1 position of the cyclohexyl group. In any substituent, the number 1 position is the position directly connected to the parent chain. So this would be the number 1 position. Therefore, this is number 2, number 3, and number 4. My methyl group is coming off of the 4 position. So here is the list of all the things that are coming off of my parent chain. And I'm going to have to alphabetize all of this and put it in order, and that'll take me a while. But the first thing I need to do is decide which carbon on my parent chain will be the number 1 position. And you want to choose a parent chain so that your pattern of locants is the smallest. And if I choose this carbon right here as the number 1 position, then it has 2 things coming off of it, and then you have something coming off of the 2, the 3, the 4, the 5, and the 6 positions. So if you count up the names I have here, I have 1, 2, 3, 4, 5, 6, 7 names coming off of my parent chain. So I should have 7 numbers right here. If I call this the number 1 position, then it's 1, 1, 2, 3, 4, 5, 6. If I try to start from any other carbon, it will be a 1 and then a 2. So any other position that I start from will look like 1, 2, and then you'll have a bunch of numbers that follow. And we look for the first point of difference. The ones are tied, but this 1 on top beats the 2 on bottom. So that means that this carbon right here definitely has to be the number 1 carbon. So I'm going to drop a number 1 label there. Now the number 2 carbon is a problem. If I go counterclockwise, then the substituent pattern is 1, 1, 2, 3, 4, 5, 6. If I go clockwise, then it's 1, 1, 2, 3, 4, 5, 6. So the numbering pattern is the same regardless of which way I go around the circle. When that's the case, then you have to choose the numbering pattern based on alphabetization. So at the 1 position right here, it is a 1 isobutyl, 1 isopropyl. Up here, it's a 1 isobutyl, 1 isopropyl. If I call this the number 2 position, and I'm going to have that be the top one, the counterclockwise, then it is alphabetized at the 2 position. I have a sec butyl. The sec represents a number, so we don't use that for alphabetizing unless we're trying to compare sec and tert. So at the 2 position, I have the letter B. If I go the other direction and call this the number 2 position right here, then at the 2 position, I would have the letter M. Okay? So you alphabetize things based on the first letter that you encounter that doesn't represent some type of numeric designation. So this substituent is represented by the letter B. This substituent is represented by the letter M. And there's my first point of difference. And so I want to get to the number 2 as quickly as possible. And if it's tied, then I go with alphabetization. So I'm going to go ahead and drop a number 2 right there so I don't have to make that argument all over again to myself. So I've come up with, now I know how to number the parent chain. And I have the names for all the substituents. Let's go ahead and add those numbers in. So I have a 1 isobutyl. I have a 1 isopropyl. And I know I said those in the wrong order. This is a 2 sec butyl, a 3 isopropyl. I have a 4 neopentyl. I have a 5 tert butyl. And I have a 6 4-methyl cyclohexyl group. Okay. Now I'm ready to start alphabetizing all the pieces. I've got them numbered correctly, and now I need to put them in alphabetic order. So I'm going to do that from top to bottom right here. So tert butyl is alphabetized by the letter B. So B comes before M. M comes before N. I've got a couple of I's, so they're going to come after the B, but before the M. There's another isopropyl group right there, and I'll deal with that in just a second. And then my butyl groups right here, I have to alphabetize by the only difference that they have, and that's sec versus tert. So here is a list of all the substituents placed with their correct locant numbers in alphabetic order. And what you'll notice is I have 2 separate isopropyl groups, so I need to lump those together. This is a 1,3 diisopropyl. That doesn't change any of my alphabetization because di is a numeric representation. So this I alphabetize using the letter I, and iso P comes after iso B. Okay, now I'm ready to finally kind of write all the pieces together. So we have a 2 and then a sec butyl. And then we have a 5 and then a tert or a T, either one's fine, butyl, and then we have a 1 isobutyl and a 1,3 diisopropyl, and then we have a 6-4 methyl cyclohexyl, 4 neopentyl, and then cyclohexane. And that is the full name of this compound right here using common names. That's a beast. Would I ask a question like that on the exam? Well, absolutely. Would I want to grade a question like that on the exam? No, never, ever, ever. So you can do what you want with those 2 pieces of information. Okay, those are all of the examples that I wanted to walk you through. You now, I'm sure I answered this correctly, name the following compound using common names. This question has all the common names for substituents that you are expected to memorize. So the sec butyl, tert butyl, isobutyl, isopropyl, and the neopentyl, and there they are. Yes, that was really necessary, in case you were wondering. Okay, here are the textbook problems. It was necessary because it would bug me if I didn't. And then the chalkboard problems. There are a lot of parts of these, but I intend for this to be 4 separate questions. So on the discussion board on Canvas, hopefully one student will grab compound number 1A and write the name, identify the tertiary and quaternary carbons if there are any, and identify each substituent as primary, secondary, or tertiary. So all 3 parts of that represent a single answer on the discussion board. And then all 3 parts for B. So there should be 4 separate questions on the discussion board.